Good morning, students. Myself, Dr. Shantari Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Kattanpullathu, Chennai. Today I am going to start a new topic, Decoder and Encoder. So these are the contents where first of all I will describe what is decoder, then 2 to 4 decoder and 3 to 8 decoder, and then what is encoder, and after that 4 to 2 decoder. Okay, so what is decoder? Decoder is actually the combinational circuit that changes the binary information into 2 to the power n output line is known as decoder. That means you can see the block diagram. This is a block diagram. Here there are number of inputs are n, but the outputs are 2 to the power n. If I give you an example like that, number of input n means it is 4. Okay, so if then what will be the output? 2 to the power 4. Okay, that means almost 16. Okay, so number of inputs if 3, then 2 to the power 3 is 8. In this way, that means here number of inputs are less but number of outputs are high. Okay, so here it is mentioned that binary information is passed in the form of n input line. The output line define the 2 to the power n bit code for the binary information. Now starting with 2 to 4 decoder, this is the block diagram of the 2 to 4 decoder. Here A and B are the inputs, E is the enabled input. Okay, what is the function of E? I will describe later. There are actually 4 outputs, Y0, Y1, Y2, Y3. Okay, so this is the block diagram of 2 to 4 decoder. Now coming to the truth table, here you can see the truth table. This is a enable input, A and B input, and these are the 4 output, Y0, Y1, Y2, Y3. So here you can see that 0, that means when enable, that means when enable input is 0, then when up to this the circuit will not work. Okay, so when enable input will be 1, then only circuit will be in the working condition. So when it is in the 0 condition enable, then that means whatever the combination will be in the A and B, it is doesn't matter, the circuit will not work. When it is only 1, then only circuit will be in the working condition. Okay, so what, as these are basically 2 input means that means 4 combination 0 0 0 1 1 0 1 1. Okay, and you can see when it is 0, no combinations will basically work. Okay, and in all other case there is the enable input is 1. Now I only concentrate on this. In all cases enable input is 1. It is okay. Now 0 0 combination, when 0 0 is the input, then only output Y0 will be high. Okay, then 0 1, then output Y1 will be high, then 1 0 output Y2 will be high, then 1 1 output Y3 will be high. So this is the output, these are the basically output. So how we will explain this logical expression Y0 Y1 Y2 Y3? So here I have already mentioned Y0 is actually E into A bar B bar, because 0 is represented as A bar and here also B bar. Then Y1 is actually E into A bar B. Okay, then Y3 equals to E into A B bar. Okay, and Y3 equals to E into AB. Okay, so these are the Y0, Y1, Y2, Y3, and based on this logical expression we will basically draw the circuit diagram. Okay, so here this is the 2 to 4 decoder circuit diagram, where these are two inputs and in a one enable input, and you can see there required 4 AND gates. Okay, so here also all are in the AND gate combination, so all are there require 4 AND gates. Okay, so first of all we will consider on y0. Y0 is A bar B bar. So this is y0. So one terminal is connected to E, another terminal is connected to B bar, and here also connected to A bar. Next y1 A bar B, y1 A bar, that means this is for y1. So this is the first line, this is A bar, this is B, and this is enable input. Then y2 is A B bar. Okay, y2, that means this line is goes here, this is actually A. Okay, and this is for B bar, this line is for B bar, and this is actually the enable line. Okay, then coming to the y3 is EAB. A here it is connected, B here it is connected, and enable input is this. So this is the circuit diagram. From the circuit diagram, if we explain properly, then we can see that when I will give you the two examples first. First of all, we will only consider 0-0 combination. In the case of 0-0 combination, what I have already said, that 0-0 combination output will only go at the y0. So here, if we consider here A and B 0-0, we can see that only this AND gate number 1 will work. In other all AND gate, any of the input will go 0. So, and all of you know that if any of the input of the AND gate is 0, then output will be 0. Just check this 0-0 combination. 0-0 here 0-0. That means first AND gate is connected to A bar and B bar, and E is always 1. So we at that moment we will not consider E. So A bar B bar, that means 0-0, it is 0. A is passing through NOT gate, A bar means 1. B is also passing through NOT gate, B bar means 1. So this is these A bar, B bar and E all are 1. Next for AND gate 2, we will just check. Okay, so here it is connected to B is 0. Okay, so this line is connected to A bar, it is 1, but this line is connected to B. So this line goes to the AND gate 2. So one input is 0, that means output of the AND gate 2 is 0. Okay, in this condition when A and B equals to 0-0. Second, we consider AND gate 3, it is here first line is connected to A, so this line goes to 0, that means y2 also 0. Then fourth AND gate, both the inputs are connected to A and B, so both the lines are 0-0, so output will be 0. So only when 0-0 input is there, only output goes to the y0. I will take another combination 1-1. Okay, so if there is a 1-1, we have seen that in the output y3 it actually delivers the proper output. Okay, how? Because just I am starting from this last AND gate. Okay, A and B both are 1-1. Okay, 1-1, then it is directly connected to here and it is directly connected to B. So here in the input of 4 AND gate all are 1, so output is 1. In the third AND gate, here we have seen that A, it is connected to A, so it is 1, but this line is connected to B bar, that means as B it is 1, B bar will be 0, so this will also not work. Then coming to the second AND gate, it is showing that it is connected to A bar. A is actually 1, so A bar is 0, so it is actually 0, so output will be 0. Then y0, that means we will consider at that moment AND gate 1. Here both the inputs are connected A bar, B bar, that means here A and B are 1, then A bar and B bar is 0, so it will also be 0. Hope all of you understand. So in this way, if you concentrate on 0-1 and 1-0 one by one, then you can see that in the 0-1 combination only output y1 we will get the output, and in the case of 1-0 only we will get the output at y2. Okay, so this is the case of 2 to 4 decoder. Okay, Now we are coming to the 3 to 8 decoder. So this is the block diagram of the 3 to 8 decoder. Here actually 3 inputs, and we have already said that if there is a 3 input, output will be 2 to the power n, that means 2 to the power 3, that means 8. So y0, y1, y2, y3, y4, y5, y6, y7, these are the outputs. Okay, and here also there are some enable input will be there. So here it is not mentioned, but enable input always be there. Okay, so when enable input is 1 or high, then only this 3 to 8 decoder works. Otherwise it will not work, whatever be the combination of the input will be there. Okay, so let's start. So this is the truth table. Here already I have shown that this is 0 condition enable, that means no input combination will work. So it is cross it is mentioned, so output we will not get anywhere any output. Okay, then in all other combination enable input will be 1. So now we will take the as it is 3 variable, so we will get 2 to the power 3, that means 8 combination we will get. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Hope all of you know how to design this. This is actually 4 to 1 combinations. Okay, so you can see that in the case of 0 0 0 we will get the output only in the y0 combination, and when 0 0 1 that means y1 combination, 0 1 0 that means y2, 0 1 1 that means y3, 1 0 0 that means y4, 1 0 1 this is y5, 1 1 0 y6 and 1 1 1 this is actually 7, so y7. So these when that means 0 0 0 is mentioned in the input, then output only goes to the y0. In this way same process will continue other inputs also. So the logical expression for y0 to y7 are already I have written here. Y0 means E is always will be high, so E into A2 bar, A1 bar, A0 bar. Okay, then Y1 equals to E into A2 bar, A1 bar and A0. Okay, then Y2 equals to A2 bar, A1 and A0 bar. Okay, then Y3 equals to A2 bar, A1 and A0, and then Y4 that means A2, A1 bar, A0 bar, and it is also E will be there in each combination, and then Y5 equals to E into A2, A1 bar, A0 bar, A0, then Y6 equals to E into A2, A1 and A0 bar, and Y7 equals to E into A2, A1, A0. So these are the final output logical expression. Now based on this expression we will now design the circuit diagram. The question will come that in this way in any university exam, in any exam, that explain the 3 to 8 decoder with a proper circuit diagram. So here based on the output logical expression we have designed this circuit diagram. I hope all of you know how to draw. If you don't know, you go to my previous video. There I have clearly mentioned how to design the all circuit diagram based on the logical expressions. Okay, so here there are basically 3 inputs, A2, A1, A0 and the 8 output y0 to y7. Okay, so next we will start encoder. Encoder is actually just opposite of the decoder. So what is the opposite meanings? That means in the case of decoder, number of inputs will be less and number of outputs is will be high, but in the case of encoder just opposite means here number of inputs are high and number of outputs are low. So this is actually the combination circuit that changes the binary information into n output lines known as encoder. Here binary information is passed in the form of 2 to the power n lines. So here this is a block diagram. Here binary input passed through the 2 to the power n line and output will be n output. Okay, so this is actually the encoder. Now 4 to 2 encoder. 4 to 2 encoder means there are 4 inputs will be there, that means y0, y1, y2, y3 and 2 output a0 and a1. So here this is already, all these things already written, just go through it, and then next we will start the truth table. Okay, these are the input and these are 4. That means y0, y1, y2, y3. These are 4 inputs and these are the 2 outputs a1 and a0. So based on the combinations of input, actually it will select the output. Okay, so when y0 input information goes to the output, then output actually shows 0 0. So when y1 information transfer to the output, then in the output section it is shows 0 1. Okay, so when y2 information will transfer to the output, then output section it is shows 1 0. Okay, and then y3 information will transfer to the output, in the output section it will come 1 1 combination. So how we will represent the logical expression? Logical expression we have to write for a0, it will be y1, this is for y1 and y3, and this is actually only y1 and y3, for this it is y1 and y3. Okay, so this is, and a1 is actually y2 and y3. Okay, so these are the logical expression of the output a1 a0. Here actually output it is mentioned as a1 a0. Okay, now based on this logical expression we have to design the circuit diagram. This is all are in the OR formation. Okay, so first of all y3 and y1 is in the this is y3 and y1, they are passing through a OR gate and form a a0, and then again y3 and y2 passing through another OR gate, it forms a a1. So these are the combination of the encoders, that means it is 4 to 2 encoder. Thank you so much. Keep watching my video. If you have any doubt, then in a comment section please give me the comments as your doubt, so I will try to solve your doubt. Thank you so much.